Semiconductor memories. Now, these semiconductor memories are divided into two types. One is read-only memory, and another one is read-write memory or random access memory. Read-only memory means we can only read the data from the memory. Now, here there are different types are there. I will explain all these types in detail in the next lecture. Now, random access memory or a read-write memory means what? We can read the data and also we can write the data into the memory. Random access means if this is a memory, now reading and writing can be done by in any memory location with a fixed time. Now, from the starting address or from the starting location or at the end location or in between any location to read the data and to write the data, it takes a fixed amount of time. That's why it is the random access memory. Now here two types are there, static RAM and dynamic RAM, that I will explain with the diagrams in the next topic. Now here we will see the organization of internal organization of memory chips. Now this is the memory which is having the size of 16 by 8. 16 by 8 means what? 16 memory locations and each location 8 bits are stored. Now, always the memory is organized in the form of an array. Now, if you see here, these are the rows and these are the columns. Now, here this box is called as a cell and each cell is holding one binary bit. Now, if you see here, 0 to 7 means the total 8 cells are connected in a row manner. So, this what I said, 8 bits we can store in each memory location I said. Now these are nothing but what? These cells. Cell are nothing but what? Flip-flop. So it will hold one binary value. Now here 8 flip-flops are connected in a row manner. Means what? It is storing the 8 bits in a row. Now if you see all these cells are connected to a one line, that line is called the word line. Now here if you see W0 to W15 means what? Total 16 word lines are there. Nothing but what? This is one location. In this location, 16 for this location, 16 cells are connected. So this is called the word line. This is a row word line. Now if each cell, if you see, two bit lines are connected. Now here this is one bit line and this is another bit line. Now here this data this data is complement of this data. Now if you stay, now this is the b naught bit. Now here the data is available is b naught dash, complement to this bit is available. Here b1 bit is available, here b1 dash bit is available. So these two bit lines are connected to the sense oblique write circuit. Sense is nothing but a read oblique write circuit. Now for this circuit, read write signal is connected. If the processor want to read the data, if the processor want to write the data, so depending upon that, it will give signal. Depending upon that, it will insert the data or it will take the data from the cell. Now here one more control signal is there, that is chip select. Now if such chips are many, multiple chips are there, then that which chip should be selected, that is now by giving the value here. Now here bar is not there means this is active high. If we give the one, then this chip will be enabled or selected. Now, if you observe here, these sense oblique write circuit output is nothing but what? B0, B1 up to B7 means what? Total 8 binary values. B0 is nothing but a bit value or you can say binary value. Now, this is connected to the data bus. If you see data in out lines. Now, whenever the processor is reading the data, these lines are connected to the data out lines. If the processor is sending the data to the memory, then the data will be placed in the data in, and from that the data will be placed onto the bit lines. Now if you see these word lines, W is nothing but what? Word line. These word lines are driven by the address decoder. Already what is decoder you have studied in the digital electronics. Now if you are applying n inputs, then the decoder outputs are 2 to the power of n. Now here total 16 by 8 means what? 16 locations, sir. Nothing but 16 word lines are there. Now for that, how many address bits are there? So 16 means how can we write in 2 to the power of 2 to the power of 4? So 4 address lines are applied now here. by giving the four address lines. Now decoder is converting these four address lines into 16 word lines. So depending upon what data we are giving, if you are giving all zeros, then zero line will be selected. If you are giving 0001, then the W1 word line 1 will be selected. If you are giving all ones, then word line 15 will be selected. Now this is about the structure of the memory chip. Now, how the processor is reading the data and writing the data, we will see. Now, if the processor want to read the data, it will place the address on the address bus. Now, address bus is connected here. Now, that address is decoded. Now, here it is decoded. Now, depending upon the data available here, any one of the word line will be selected. Now, for example, the data word address is 0001, then the word line 1 will be selected. Now, by giving the read oblique write bar is equal to 1 and chip select is equal to 1, this chip will be enabled and read operation is taking place. So, thereby what? Now, whatever the data is available in this cell, that is placed in onto this bit line. Now, here the information and again the same complement information will be placed here. Now, that will be loaded into the sense oblique write circuit. From that it will be given to the, it will be loaded onto the data bus. Now this is how the, and from the data bus microprocessor will read the data. Now if the microprocessor want to write the data, it will give the control signal as 0 because write operation is a active low signal, so it will place 0 and it will give the address, and also it will place the data on the data input lines. So those lines are connected to these bits B0 to B7, and that information is available on these bit lines. So now if address is depending upon the address, if I take the same address, now this line is selected. Now whatever the information is available on this line, that will be loaded into this cell. Like that, processor will read the data and write the data. Now this is for the 16 by 8. 16 by 8 means total how many number of bits? 16 by 8 means total 128 bits, means what? We can store 128 bits in this memory chip. Now, for that, how many number of external connections are required? That we will see. Now here, four address lines are there and eight data lines are there. Now here you can see eight data lines are there and two control signals are there and two more are for the ground and supply to give the power supply to this IC. So two more connections are required. So total how many number are there? So total 16 external connections are required. Now to understand the concept easily, we have taken the 16 by 8, that is nothing but a 128 bit memory chip. Now if 1 kilobit 1 kilobit means what? 1024 1 kilobit bits wanted to store, then 1 kilo is nothing but what? 1024 bits need to be stored. Then how many number of external connections are required? So this 1 kilobit we can also write it as 128 into 8. So 128 locations are there, and in each location 8 bits we are storing. Now for this, how many number of external connections are required? 128 means how can we write? This is 2 to the power of 7 and 8 data lines. So total 7 address lines, 8 data lines, 2 control signals and 2 power. So total how many? 19 external connections are there. So instead of instead of the designing the memory chip, there is another alternate method is there. Now, just now we have seen that 1 kilo bits, how can we write 128 into 8? Then how many external connections are required? 19 connections are required. Now instead of designing the 1 kilobit memory in this manner, now if I try to design 1 kilobit memory is a 1 kilo by 1 bit means what? So total here I have a 1024 locations are there. In that I am storing only 1 bit. Now in this case what? The same capacity but 128 locations are there and each location 8 bits are stored. Instead of this, if I store like this, then how many number of external connections are required? We will see. So 1024 is nothing but 1 kilo. So total how many? 2 to the power of 10. So total 10 address lines are required. 10 address lines. How many data bits? Data bits are only one and two select two control signals and two power supply. So total how many here? 15 external connections are required. Now if I format the if I write the 1 kilobit in this format, then I required the 19 external connections. If I write the in this format, then I required only 15 connections, external connections I required. Now, if I'm designing the 1 kilo by 1 bit memory chip, then I need the 10 address bits. So those 10 address bits are divided into 5 bits per the row and 5 bits per the column. Now again, this is the decoder. Already, what is decoder? If you apply n input, then it will generate the 2 to the power of n output lines. So by giving the 5 row addresses, it will generate the total 2 to the power of 5 is nothing but a 32 rows. 32 word lines are 32 rows we can say. So always memory cell is arranged in the organized in the array manner. So rows are there and also columns are there. So now by using the upper, so if this is the 10 address bits A0 to A9, then in this upper 5 bits are used for the row address and the lower 5 bits are used for the column address. So by using this, it is now it is going to select any one of the by using these 5 bits, it is going to select any one of the row. Now by using the lower bits, now these lower bits are applied to the 32 to 1 output multiplexer and input demultiplexer. Now for the read operation, data should be taken out. That time it will be acting like a multiplexer. Now for the writing, it will be act like a demultiplexer. Now these are the nothing but a select lines. Depending upon the lines, now in this 32 column bits, it will select any one of the column. So depending upon the address, lower address, it will select the any one of the column. Now this is the row selected by using the upper address bits and this is the column selected by using the lower address bits. Now this is the cell. In this cell whatever the data is there, that will be read or that will be data will be written into that cell depending upon the read write signal. So now this is the another alternative method to design the memory chip. Now here to understand the concept again we have taken only 10 kilo. But in general if we see, so there are the huge memories which will store the in the order of mega. Now if I take 4 megabit chip, then how to design this? This 4 megabit I can write it as 512 kilo into 8 means what? These are the memory locations and each location I'm storing the 8-bit data. Now here I have taken the 1-bit data, but usually the memories which are available in the market are byte addressable. Means what? In each location 8 bits are stored. Now in this case, how many address locations are required means address lines are required means what? Now this you write in the form of 2 to the power. So kilo can be written in the form of 2 to the power of 10 and 512 can be written in the form of 2 to the power of 9. So total 19 address lines are required to design the 1 megabit chip. Now this is the internal organization of the memory chip. In the next lecture, we will see the types of RAMs.